Hello and welcome back to Maths with Mitch. Today we are going to be using the trig identities that we looked at in the last video to verify equations, or you might be asked to verify different identities. So we're going to be using the identities that we looked at last time, the fundamental identity, cos squared theta plus sine squared theta equals 1, and then the two others that we derived from that fundamental identity. So let's look at our first question. We might be asked to verify. So verify, you're going to be trying to prove something is true. So you're going to be given an equation and try and prove that left-hand side does in fact equal the right-hand side. And this one we're going to do is 1 over 1 minus cos theta plus 1 over 1 plus cos theta must equal 2 cosec squared theta. So we're going to be trying to prove that the left-hand side does in fact equal the right-hand side, so verifying that equation. We're going to be wanting to look at what we've got in the fundamental identities and think, can we put something in that form, remembering that we can change those around and make different things the subject of those equations. And we want to take the left-hand side and the right-hand side in turn and try and see if we can do that. So let's firstly take the left-hand side. Now remember, always write down each step that you're taking. And there's nothing wrong with making a note at the side, letting the examiner know what you're doing at each step. So firstly, let's add these fractions together and bring them together as one. So we're going to be cross multiplying the top. So 1 plus cos theta plus 1 minus cos theta. That is timesing that and timesing that, getting them on the top and then timesing the bottom. So we have 1 minus cos theta times by 1 plus cos theta. And again, as I say, we can say what we've done. And we've added the fractions. And now if I can simplify that down, so we can get one single term on the left-hand side and then look if we can get that in the form of something in the identities. So we have a 1 and a 1, so we're going to have 2 on the top. Then we've got a plus cos theta and a minus cos theta. So that's it. That's all we've got on the top there. And then if we times out the bottom, we have 1 times a 1, a minus cos theta, a plus cos theta, which are going to cancel, and a negative cos squared theta. And we can then write that out a bit neater. So we have 2 over 1 minus cos squared theta. So there we've simplified. Now, what have we got anything here that we can now use with the identities that we've got? Well, we've got 1 minus cos squared theta. So we can look at our identities. We've got a cos squared theta here. Get the pen to it. We've got a cos squared theta here. However, what we can think about is if we were to minus cos squared theta from this side and minus cos squared theta from this side and make essentially making sine squared theta the subject, we end up with sine squared theta equals 1 minus cos squared theta. And as luck would have it, that is exactly the term that we've got on the bottom. So we know we can sub sine squared theta in for 1 minus cos squared theta. So we can put sine squared theta in, and that leaves us with 2 over sine squared theta for the left-hand side. Remembering that what is the reciprocal of sine squared theta? It is cosec. So remember, you can write down what we've done at each step. So we've subbed in the identity there, and here we can say 1 over sine squared theta equals cosec squared theta. We know that. So 2 over, we end up with 2 cosec squared theta. So that leaves us with that term there. And recalling that at the beginning, that indeed was our right-hand side of the equation. So what we've now done is prove, using the fundamental identity subbed in, that the left-hand side equals the right-hand side. So we've used the fundamental identity, sub it in, and proved it equals the right-hand side. So what you're looking for is to try and evaluate the terms in the left-hand side or the right-hand side, whichever is going to be the right one for you to use. Evaluate it and simplify those terms and try and get them into a form that you can sub in one of the identities that you've got available to you to then be able to show that it equals the other side of the equation. So let's look at another one now. Let's say we are asked to verify 1 minus sine theta. I do apologize, my thetas are terrible. That is what you get when you sketch them out and trying to do them quick. I'll make a bit of an attempt to do it a bit neater. Let's see what we can do here. Much better. Okay, and that is equal to cos theta. So here we are. We've got a completely different term this time, but we're going to be following the same process. We're going to be trying to use those same trig identities, to sub in and to try and help us to verify this equation. So again, what we're going to do is we're going to start with the left-hand side. We've got a cos squared on the right-hand side. There's not much we're going to be able to do with that. We've got lots of different terms in the left-hand side. Let's see if we can try and simplify them into a form that we can get them to equal cos theta. So let's take the left-hand side. Your first steps generally are going to be trying to get that all into one term, evaluate it, simplify it down, and then see what you can do with it. So let's if we combine all that fraction into one, and let's work on that. So remembering that 1 is essentially 1 over 1, so you can cross multiply and do this fraction. So we end up with 1 plus sec theta minus sine theta tan theta, all divided by, and that would be, if you were to write out in full, 1 times this here, but we know 1 times that will just leave us with 1 plus sec theta. So that's the first step. We can now look at how we can simplify this down. So what we know we want to do is to try and get something in the terms of cos theta. That's what we're looking to do. So let's think, what have we got on the bottom here? We've got sec. Sec is the reciprocal of cos. We've got sec on the top as well. So what if we times top and bottom by cos? Remembering, you can times it by anything, that doesn't matter, as long as you do the same to the top and same to the bottom. And then we end up with, remember, sec is 1 over cos, so if you times it by cos, that then becomes a 1. Then this term is a little harder. If you times something by cos, but we've got a sine and a tan. So tan is sine over cos, so when you times it by cos, that just becomes sine again. And we then have the original sine there, so that ends up with sine squared theta. And then on the bottom, we're left with cos theta is the 1, and then sec, just said, times sec by cos, you end up with 1. So there we are, that's cos theta on the top and bottom. So next step, we can simplify that down. Let's think about the ones we have in there, what we can do with it. Okay, so we've now got it down into one term, and that's probably about as good as we can do at the minute. So now we can look at the terms and think we want everything to have just cos, because we've got cos on the right hand side, so we just want to have cos on the left hand side. So is there anything there that we can see that looks familiar to us. And remember from last time we used the fundamental identity in the form of 1 minus cos squared theta. Well, now we have this term here, 1 minus sine squared theta. So is there something we can possibly do there? So let's remember our fundamental identity. Cos squared theta plus sine squared theta equals 1. So how could we end up with it in this form? Well, what if we minus sine squared from both sides? What do we get then? So if we minus sine squared theta on both sides, we get left with cos squared theta. They've cancelled, so we're left with 1 minus sine squared theta. And fantastic, look at that. That is exactly the form that we are going to use. So we are going to, we've got that in our equation, so we can sub in cos squared theta. So let's do that in the next step. We now have cos theta plus cos squared theta divided by cos theta plus 1. So where do we go from here? So what have we got here? So our next step is to try and evaluate this down and simplify this. So we know cos squared theta. What is that cos squared theta? That is cos squared cos theta times cos theta. So we can bring that out because we have cos squared as a common term into here and here. So that leaves us with 1 plus cos theta. And on the bottom, we have cos squared plus 1, which is it. Doesn't matter which way around you write it. We can write it as cos squared 1 plus cos squared plus 1, same thing, but we'll change it around just so you can see it neatly from the top and bottom. And now you can see that that divides through by that. They'll cancel, and what we're left with is cos theta. And if we remind ourselves back at the start, that equals the right-hand side of that equation. So what we've done is proven and verified that that trig identity is in fact correct. So to recap the steps, what we've done is evaluate the left-hand side into one term. We've simplified it down. We've then looked for something we can sub in from the fundamental identity that we had, or from some of the other identities that you might have in either your mind or your formula paper. And once we've subbed that in, we simplify it down and find it to be equal to our right-hand side.